A very large, a very large impulse is provided in a very small time. That means large impulse in small time interval. That means momentum is changed very fast. Sudden change in momentum. Sudden चेंज इन मोमेंटम. जैसे आप किसी से टकरा जाते हो तो आपका मोमेंटम पहले कुछ होता है, टकराने के बाद हो सकता है अचानक से जीरो हो जाए. एक कार बहुत फास्ट स्पीड से आ रही है और वो कहीं टकरा जाती है तो उसका मोमेंटम बहुत फास्ट चेंज होता है. सो एनी फास्ट चेंज, सडन चेंज ऑफ मोमेंटम may be known as a collision. Okay.
Okay.
And collision we can categorize into two types. First, we can say it is an elastic collision. Elastic collision, and second you can say inelastic collision. In elastic collision. Let's first discuss about elastic collision. What happens in elastic collision? First of all, in any type of collision, there are two property. One property that will be always universal. First property is in any type of collision, the total energy or total linear momentum. Total linear momentum of the system. System means the two bodies taken in a system. System means the bodies that are there colliding of two bodies. The total linear momentum of system remains conserved. Remains conserved. What does it mean, Neil? That initial momentum, that is momentum before collision, is equal to momentum after collision. If I take one particle of mass m1, which is moving with the velocity u1, and it collides with another particle of mass m2, which is also moving with the speed u2. If I imagine that u1 is greater than u2, then it might happen that after some time, the collision will, the m1 will go and collide with m2. M1 and m2 both are colliding here. Let's suppose the collision happens. During collision, it might be, you can see that m1 is applying force on m2 towards right, and m2 will also apply force on m1 towards left. Both forces are equal and opposite, F1, because that is action reaction. So what you feel that M1 was moving towards right, but force is acting towards left. So M1 might be slowed down. M2 was moving towards right and the force is also acting towards right. So M2 speed might increase. So after collision, what may happen? That the speed of M1 now becomes V1 and speed of M2 or the velocity of M2 becomes V2 due to this interaction force. So the rule says that I have written here that total linear momentum remains conserved. It means momentum initial. Initial means before collision, final means after collision. So initial momentum, we can say it is m1 u1 plus, always we have to give vector sign because momentum is a vector quantity. This is the initial momentum before collision, and that should be equal to final momentum m1 v1 plus m2 v2. That formula is always applicable in all type of collision. It may be elastic, inelastic, that you can write. Understood, Neil?
Yes, sir, understood. Just one second.
Yes.
Yes, sir.
Okay. Second property is the total kinetic energy of the of the system remains conserved. The total kinetic energy of the system remains conserved. It means again kinetic energy before collision is equal to kinetic energy after collision. So initial kinetic energy should be half m1 u1 square plus second particle was moving with u2 speed half m2 u2 square. And here after collision we can write half m1 v1 square plus half m2 v2 square. This two formula is always applicable in elastic collision. Kinetic momentum gets conserved and kinetic energy also will be conserved. Now, if I say what is inelastic collision, what is inelastic collision? So, inelastic collision, one rule is correct that I told you it always true for any type of collision. That is the total linear momentum remains conserved. There is no problem in this. The total linear momentum remains conserved. That is okay. That is, there is no issue in that. Maybe what type of collision is this? M1 U1 plus M2 U2 will be always equal to M1 V1 plus M2 V2. It is always correct. But the second is not correct here. Kinetic energy does not remain conserved. And what happens with kinetic energy? There is a loss in kinetic energy. Kinetic energy being lost in total kinetic energy. It means that the final kinetic energy will be less than kinetic energy final will be less than kinetic energy initial. So this you cannot conserve. Okay, Neil,
Okay, sir.
you understood the difference between them?
Yes, sir, I understood.
Is it right?
Yes, sir, done.
Okay. Now in detail I discuss. First I discuss elastic collision. Elastic collision always happens in smooth surfaces. So I told you that if I have a particle of mass m1 which is moving with the velocity u1, I have another particle m2 which is moving with the speed u2. They collide, and after collision I saw that now m1 is moving with the velocity v1 and m2 is moving with the velocity v2. I told you there are two equations. First is conservation of momentum, that is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. M1 you can bring this side. So this is U1 minus V1 is equal to M2. This is V2 minus U2. That you can take as equation 1. Second thing I told that you can also conserve the kinetic energy in case of elastic collision. So you can also write here half M1 U1 square plus half m2 u2 square is equal to half m1 v1 square, that is kinetic energy before collision, and that is equal to kinetic energy after collision. Half I can cancel, and m1 term I keep one side, so v1 square will come here. It becomes u1 square minus v1 square, and m2 also I'll take on the right side, so that will be v2 square minus u2 square. That you take as equation 2. Now what I'll do, I am going to divide equation 1 and equation 2. Okay, what I'll do, I'll divide equation 2 divided by equation 1. So equation 2, I have m1 u1 square minus v1 square, and that you are dividing with the first term here, this, that is m1 into u1 minus v1. On the right hand side we have this term here, that is m2 v2 square minus u2 square divided by, and here the right hand side term is m2 v2 minus u2. m2 cancel, m1 also cancel. Now I can write that u1 minus b1, a square minus b square, I can break it like u1 minus v1 into u1 plus v1, and that is divided by, this is u1 minus v1. This also I'll cancel. On the right hand side, this is also a square minus b square, so I can write v2 minus u2 multiplied by v2 plus u2, and that will be again v2 minus u2. cancel. So you got here u1 plus v1 is equal to v2 plus u2. This is a very important relation that also I can write in this form. U1 minus u2 is equal to v2 minus v1. So u1 minus u2 is the relative velocity before collision, and v2 minus v1 is relative velocity after collision. So this we call as u1 minus u2 is called as velocity of approach. How the two particles are coming close to each other before collision. This is always before collision. And this is called velocity of separation. After collision, they will be separated from each other. So in elastic collision, what you see that the velocity of approach is always equal to velocity of separation. Understood, Neil?
Yes, sir. Understood. Just one second.
Yeah.
Yes, sir. Done.
Okay. So this is a very important property of any elastic collision. Whatever velocity of approach will be, same will be velocity of separation. Like if you throw a ball towards a wall, अगर एक बॉल को आप दीवार की तरफ थ्रो करते हो, तो जिस स्पीड से वो दीवार की तरफ जाएगा, मान लो वो दीवार की तरफ जा रहा है 10 मीटर पर सेकंड के स्पीड से, तो दीवार से टकरा के वापस भी उसी स्पीड से आना चाहिए 10 मीटर पर सेकंड से. मतलब जो वेलोसिटी ऑफ अप्रोच था वही वेलोसिटी ऑफ अगर सेपरेशन भी है, तब हम कहेंगे कि कॉलिजन जो है वो इलास्टिक है. ओके, अंडरस्टूड?
Yes.
Now Let's understand few cases also. Or first derivation. It's not a derivation. How you solve the numerical that I am saying. Sometimes they ask you find velocities of particle, velocities of two particles that are colliding with each other after the collision, after elastic collision, after elastic collision, velocities of particles after elastic collision. So let's suppose, again I am taking the same example, Neil, that m1 was initially moving with velocity u1, m2 was moving, m2 was moving with velocity u2, and after collision what happens, they collide, and after collision their velocity changes. m1 is now moving with the speed v1, and m2 is moving with the speed v2. This all velocities you should show by the vector sign. Wherever the directions is different, you have to use the negative sign. This I am discussing now head-on collision. I have not discussed the oblique collision, that is collision in two dimensions. I am discussing collision in one dimension only, that is also called head-on collision. Now, what is head-on collision? Head-on collision is initially they were moving along x-axis. Now after collision also they are moving along x-axis. So that line has not been changed. That's why that is called head-on collision. Now I told you two equations. First, I told that momentum gets conserved, that you can write m1 u1 plus m2 u2, and that is equal to m1 v1 plus m2 v2. That is the first equation, conservation of momentum. I also told you that velocity of approach, that is u1 minus u2, is equal to velocity of separation v2 minus v1. v2 minus v1 I am writing in this way, minus v1 below m1, and here I write plus v2. v2 minus v1 I am writing in this. This two equations I have. So in problems, what will happen? Two equations will be, now some numbers will be given, so you can solve the equations there itself. But here I am trying to give you a formula. If I solve these two equations, solving equation 1 and 2, how I am solving, that is mathematical thing. Just I am writing the velocity formula. If you try to find v1, then it will be m1 minus m2 divided by m1 plus m2 into u1 plus 2m1 into m2 divided by m1 by m. I'm not saying that you remember these equations completely. You only have to write these two equations and you can solve mathematically how we solve the equations. But if you remember this, and remembering this is not that tough, I'll tell you. When you started v1, you write m1 minus m2. When you try to find v2, then just reverse it. You start from m2 minus m1. That is the difference. m1 plus m2, and here you have multiplied with u1. If you're finding v1, now for v2 you should write here u2, and this will be again 2m1 m2 divided by m1 plus m2 multiplied by u1. So that If you remember this two formula, that will be more easy. Otherwise, this equation solving also will give you the same answer. Okay.
Okay. Okay. 1 second. The- oh,
Yes. Work energy power study package you had different. I think it was second, right?
work energy power. No, I think it was the third study package, not the second.
Third, you have a system of particles, gravitation, and mechanical properties of solids. I think it must be in second. What I guess you only have sent this third package. Third package contents are a system of particles and rotational motion, gravitation, and mechanical properties of solids.
Yes, sir. I think it's in the second package only.
Second package. So if second package also you will send me, then I'll able to tell you which question you have to send. Okay, which
Okay.
question
We'll
you have
try
to
to
solve
send it by tonight only, if possible.
today.
Yes, yes. We'll try. We'll try.
Yeah, yeah, sure, sure. Then few questions I'll tell you for collision that you should try that.
Okay. Sure. Yes, sir. Done.
Okay. If you take few special cases, like if I say first case I am taking, if M1 is very, very less than M2 and M2 is at rest, second particle is at rest. So you can ignore M1 in this formula. In this formula, you can ignore M1 because M1 is very, very less. So an M2 is M1. If I ignore 0, 0 minus M2 will be minus M2. U1, here also M1, if you ignore, you will get M2. And this second particle is at rest means U2 is 0. So this u2 is 0 means this complete term will be also 0. So what you get that in that case, v1 is going to be equal to minus of u1. And if I try to find v2, then here u2 is 0. That's why it is 0. And here m1 I am ignoring. So this will be also 0 because u1 is there, but m1 I am making as taking ignoring 0. So this also becomes 0. That means v2 remains 0 and v1 becomes negative of u1. It does mean that like a ball is going to say, let's suppose it's a very simple example, a ball m is moving with the speed of 10 meter per second. Let's suppose this is the example that I am taking, and here is a wall. So you know the wall moment mass is very very high as compared to the ball, and the wall is at rest. So when the ball is going, its speed is u1. Now coming becomes minus u1. That means after colliding, the ball will return with the same speed 10 meter per second, but negative because there is opposite direction. So this example you can apply when a ball is moving towards a wall. In that case, v1 is equal to minus u1. The ball will, that means the ball will return with the same speed, and v2 equal to 0 means the after collision also the wall will remain at rest only. Wall will not move. Do you understand this special case, Neil?
Yes, sir. Yes, sir. I'm understanding.
Please write.
Yes, sir. Done.
Okay, good. Let's suppose m1 is very very large mass as compared to m2, and m2 is still at rest. That means u2 will be 0. So it's like a case that when a very large particle of mass m1 is going to strike a very small particle m2, m2 was at rest and m1 was moving with the velocity u1. Now after collision, if I try to find v1, I know the formula of v1 starts with m1 minus m2 divided by m1 plus m2, and I'm finding v1. So first I write here u1 plus 2 m1 m2 divided by m1 plus m2 into u2. Now as I said that u2 is 0, and here what you find that m2 is 0 because m2 is very very less. So m1 will be cancelled here. So you will get here v1 equals to only I'll write m1 u1 divided by m1, and this u2 is 0. So this is 0 only. This is cancelled. So what you find that v1 will be equal to u1. That means after collision there will be no change of the velocity in the first particle. After collision there will be no change in the velocity of first particle or larger particle. You understood this?
Yes, sir. One second.
Yeah. No, just a minute. I'll complete it. If I try to find v2 nil, now v2 formula is m2 minus m1 divided by m1 plus m2 into u2 plus 2 m1 m2 divided by m1 plus m2 into u1. So what you find here, this u2 is 0, so that first term is 0, and second term you can ignore m2. So m1 it will be 2 times u1, it will be 2 times u1. So what you see that v2 becomes 2 times of u1. So the velocity of the smaller particle becomes twice velocity of smaller particle. Smaller particle becomes twice of the velocity of larger particle. Velocity of larger particle. Is right.
Yes, sir.
So if I take one example here, that at a very large particle is moving with the speed of 5 meter per second, and here is a very small particle that is kept at rest. This is before collision. This is before collision. So if I say after collision, after collision, after collision, what happens? This big particle will keep on moving with the same speed, 5 meter per second, but the smaller particle will move with the double speed. It will move with the 10 meter per second. That only, that the case only we have discussed. Understood? So one more case I am going to discuss, third case. Third case is if M1 and M2 both are equal. That means two equal mass particles are colliding with each other elastically. So you see, V1 formula again I am writing to, this will be M1 minus M2 divided by M1 plus M2 into U1 plus 2 M1 M2 divided by M1 plus M2, and that is U2. And V2 also, V2 starts with M2. So M2 minus M1 divided by M1 plus M2 U2 plus 2 M1 M2 divided by M1 plus M2 U1. So if M1, M2 in both place, I'll try to put M only. So this will be M minus M, this will be 0. And this will be 2M into M, 2M square U2 divided by M plus M will be 2M. So what you find here, what you get here, V1 2M, just a minute. I think I have just one small mistake I have done. Here it is only 2M2. Please change it, okay? Because dimensionally it is coming wrong. Not
Okay.
M1, not M1, and in V2, M2 will be V1, here will be M2, V2 will be M1. This will be also, you can tell. First, you do this change, okay?
Yes, sir. Done. Done.
One more place I have written for V1, here will be M2. And V2 here will be M1. Otherwise, if I am canceling here, then what would happen? One M is left. That is not possible. Dimensionally should be correct. Okay. Okay. So this is M only. So M will be cancelled. So what you get here, you will get V1 is equals to, and this is also 2 is also cancelled. So V1 will be equals to U2. And similarly, if I try to find V2, so this is M minus M will be 0 because both are equal. And here it is 2M divided by 2M into U1. This will be cancelled. So what we get here, V2 is equals to U1. So you see that V1 becomes U2, V2 becomes U1. So what was collision? What was the speed of the first particle before collision? That becomes the speed of the second particle after collision. And what was the speed of the second particle before collision? That becomes speed of the first particle after collision. It means you can say that the velocities of two particles, velocities of two particles get exchanged after elastic collision. Please write it, Neil.
Yes, sir. Done.
Okay. Now let's discuss different type of collision. First collision we have discussed, that is elastic collision. Now let's suppose I discuss partially elastic collision, not perfectly elastic, partially elastic, or you can say partially inelastic. Both are same thing only. If something is partially elastic, means it is also partially inelastic collision. Okay. Now, partially elastic or partially inelastic collision. Here what happens, there is a loss of kinetic energy. Momentum remains conserved only. Momentum is always conserved, I told you. The total linear momentum remains conserved, remains conserved, but there is a loss of kinetic energy. That is the only difference. Kinetic energy does not remain conserved. That is the difference between elastic and partial elastic. There is a loss of yeah, there is a loss of kinetic energy. So here you have you can only use one equation, that is m1 u1, conservation of momentum. You can use, no problem, but conservation of kinetic energy you cannot use, because that is not conserved. This we can use here, m1 v1 plus m2 v2. But to solve, we need one more equation. We cannot solve a linear equation with only one, because we have two variables. So now, if I say another equation, so very good equation is there. Here, velocity of separation is not equal to velocity of approach. Velocity of separation after collision, with what velocity they will separate, that is not equal to velocity of approach. That is some less means we can multiply with some constant e times of velocity of approach, e times of velocity of approach. What is e here? E is called coefficient of restitution. E is a constant, that is called as coefficient of restitution. So if I say what is the formula for E? Formula for E, you can write here. It is velocity of separation. Velocity of separation separation divided by velocity of approach. So velocity of separation is basically v2 vector minus v1 vector, and velocity of approach is always first vector u1 minus u2. So you can say that E formula is v2 minus v1 divided by u1 minus u2. So now becomes the second equation that I can write as v2 minus v1 is equal to E times of u1 minus u. That is the second equation that we can use. So this was the first equation. This is the second equation. And if I solve these two equations by solving equation 1 and 2, you can solve it in the exam, and so and any problem you can find the solution. But if you want to remember the formula, that formula is also not that much tough. V1, you should start with m1 minus, in place of m2 you should write E times of m2. Rest will be same, m1 plus m2 multiplied by u1. And the second is 2, in place of 2 you should write 1 plus E. V1 you are trying to find, the second terms will be m2 u2 divided by m1 plus. If I try to write v2, then I should start with m2. So m2 minus E times of m1 divided by, this is m1 plus m2 multiply with u2. And here again, in place of 2, I should write 1 plus E. And am I trying to find v2? So second term will be m1 u1 divided by m1 plus m2. So this is the formula that we use for partially elastic collision. Please write it, Neil.
Yes, sir, I'm writing it down. Yes, sir, done.
Okay. Like if I say, if I take one example here, let's suppose there are two particles. This is of one particle here, and let's suppose one particle here. It is of mass 2 kg, it is of mass 3 kg. 2 kg is moving with the speed 4 meter per second. 3 kg is moving with the speed 2 meter per second. And the coefficient of resistance, the value is given 0.5. Remember, always the value of E is between 0 and 1. So they can, here they're asking, find the velocity after collision. Find what will be V1, find what will be V2. So V1, I told you, V1 will be M1 minus E times of M2 divided by M1 plus M2 into U1 plus 1 plus E into M2 U2 divided by M1 plus M2. So M1 is given 2, E is given 0.5, M2 I'll take as 3 divided by, this is 2 plus 3, M1 plus M2, and U1 is given as 4 plus, again here 1 plus E, that is 1 plus 0.5, M2 is 3, U2 is 2 divided by 5. That calculation only we have to do. This is 1.52 minus 1.5 is 0.5. So 0.5 multiplied by 4 divided by 5. This is 6 into 1.5 into 6 is 9. 9 divided by 5. This will be 2 by 5, 9 by 5. Answer will be 11 by 5. That is 2.2 meter per second. That I have found for V1. Understood, Neil?
Yes, sir, understood. One,
Yeah.
yes, sir, done.
Okay, we'll discuss in the remaining top perfectly in lastly discuss in the next class. Okay,
Okay. Okay.
okay, bye,
Bye, sir.
bye.